Hello everybody, welcome back for another installment of Ridiculous Cart. I think this is part 3 of the ongoing saga, and I started to do some things before I got too far down the rabbit hole. I wanted to start recording a little bit, and maybe we'll turn this into an episode or something. So, 2 changes, well, I guess 3 changes since last time. One, I added a reset switch, because, hey, you never know, could come in handy. That's just real simple. It just takes reset to ground, resets all over from that chip and that chip, so quickie, easy install there. I can flip it over and show you later if you're really interested, but it's uneventful. More eventful is this blue wire. This is bridging pins 10 and 24 on the CIA chip, and that is port B, pin 0, and that is the flag pin that is used to generate an interrupt, and we'll talk a little bit more about that later. But those two are bridged, and the other thing is, if you notice, there's one little red pin header down the end there. I wanted more power. That's just another place to grab 5 volts from. So all that is because I want to do serial port things. Little history on the CIA and the Commodore 64 is that, of course, they went cheap, and they did not put a real UART on there like a 6551, or some people might be more familiar with the more common 8250 or the 16450, 16550 UARTs that you found in PCs. And there's still kind of a flavor of that chip floating around in the chipset of modern computers today. But at any rate, they use the CIA and basically a software driver to do the RS232 kind of stuff, and that's all built into the kernel. Doesn't have to be. You can write your own software too, but there are kernel routines available on the C64 that will utilize a couple of pins on the JCIA to do transmit and receive RS232 style. Maybe we'll just pull up the document here in a second, but there's also clear to send, ready to send, all those other kind of signals. We're not going to bother with those yet. I just want a very, very slow and simple serial connection coming out of this thing, and we can start hooking things up to it. So all that to say, we're going to model what we do circuit-wise, wiring-wise, against how the user port is pinned out on the Commodore today. So we're going to hook up a couple of wires here, and let's see if I can do this on camera without mangulating anything too bad. We're going to use this orange one on what is the receive for the JCIA's serial port, and 1, 2, 3, 4. Pin 4 is going to be pin PA2, port A, pin number 2, and that is going to be the transmit pin. So we're receiving on these 2 pins here and transmitting out of the single pin here. We have those wired into a level shifter. Is that going to focus? Maybe. Yeah, there we go. And this is just a 5 volt to 3.3 volt level shifter. Actually, it's kind of whatever voltages you want within reason. It depends on what you feed it. So on the HV side, the high voltage side, is where we have our CIA plugged into, because that's going to be the 5 volt side of the world. And then we can ground it. Pin 1 over here is a ground, and then we got to feed it 5 volts. So we can pop that down here on pin 20. Yep. And basically we have all the same jazz coming out of there, right? And we have the orange and yellow for the transmit and receive, and white and black on this side is going to be our 3 volt and ground, and we have that going to a little SP32 module. Can we see what he is? W room something. Yeah, W room 32. It's just a ESP32 dev kit board, and he's just hooked up to the transmit and receive pins on here. Obviously opposite, transmit on the SP is going to receive on the CIA, which is pin 10, and then receive goes transmit on the other side. All right, not rocket science here. We're grabbing our 3-volt and ground to feed into our level shifter, and you know the SP is pretty resilient. It'll tolerate 5-volt, but you know, cheap insurance. I have these things laying around. I think I got 20 of these for a couple of dollars or something. So no harm in putting a level shifter in there. And this is the circuit we're going to be playing with today. So the wiring's as simple as that. Software is going to be the hard part. So now we have to come up with a way to get the C64 to realize there is another CIA with a serial thing hanging off of it and start talking to it. So let's go play with some software. All right, just to recap the wiring a little bit here. This is the user port pinouts. This is what allpinouts.org or com or whoever they are. All pinouts. Google them. They're awesome. They have all kinds of neat stuff on there. Anyway, so there's all the different signals you'd see on a typical RS232 port, except we don't care about most of them. We're not going to deal with any kind of flow control or anything like that. This is just very, very basic comms. Maybe later on if we need flow control, we'll get into it or something, but I'm not anticipating doing anything high speed with this thing. Unfortunately, to do the 9600 baud user port modem hack kind of thing, you need 2 CIAs for that. I don't think I'm going to put a second one on this cartridge. That's just kind of ridiculous. But I guess this thing is ridiculous, so who knows. But anyway, moving on. We're just going to do low speed stuff for now just to see if we can learn something and do something. So here's B and C, flag 2 and PB0 pins on the chip that we have bridged. That was 10 and 24. And then where's PA2 would be your pin M if you're using a traditional user port interface, edge connector kind of thing. And that's our transmit data. So that's all there is about that. So as far as talking to all this, here's what I did. This is the source code for the user port modem driver. This is just for 300 to 2400 baud. This is not the UP9600 hack. This is just the good old school user port modem driver that came with Novaterm. Striketerm uses this source code, and yeah, we're just gonna take it and make some very simple edits to it. Before we get into addressing and stuff, one thing I found had to be changed to use the 64 TAS compiler on the PC is that it does not like BYT. It wants byte written out. And other than that, the compiler seems to be happy with this code. So that was just a quick search and replace, change BYT to BYTE to simple. And then here's all our addresses that we would typically talk to. DD00 is the second CIA inside the machine that would normally control the user port edge connector. We are running our additional CIA at DE60, so this again was just a search and replace for DD0 to DE6, and there were 44 iterations of that in here. Excuse me. And I have some ideas later to replace this with variables and make our lives easier, but for now, search and replace is good enough. I am not a programmer. So the only thing I found that kind of threw me for a loop was in 2 places. If you see here, the ring check and the character check, I think that's what car check is. It's waiting for character input. It actually references DD01 in its decimal form instead of using its hexadecimal form. And I don't know why they did that. Maybe it was laziness, oversight, nobody cared that much. I don't see why you couldn't have just used hex here as well. So that's something, again, we'll play with later to see if we can kind of streamline and standardize this code. So we changed that to its decimal equivalent for the DE6 registers, and that's that. So this code ought to work. So I will fire up a DOS window here for compile stuff and see if it comes together. Alright, so this ought to work, I think, maybe. 64 task.exe, we're just calling our source code file and outputting to serial.upcartde60. This is how Novaterm likes to see file names so that it can pick them when you go to choose a modem driver inside of the software, inside of Novaterm itself. So compiled, it's good. We will get this loaded up on probably an SD to IEC would be easiest, and we'll get it loaded up and see if we can talk to this thing. All right, I think we're ready to give this monstrosity a rip. I have everything all wired up. There is an extra wire here now. This is the power for the ESP32. It's coming off that extra pin I put on there earlier. So we're all jimmied together. We have power, and just set that down somewhere where hopefully it doesn't short out on anything. And there is the new D64 image I put together of Striketerm with our new driver on it. So we'll get him mounted and running. And it ought to load pretty quick. Something to note here too, with Novaterm, it does not use any of the kernel calls for serial communication. So you can use other kernel ROMs, that have removed serial stuff, like your, Jiffy and Jaffe DOS and a whole bunch of the other speedloader ones pulled out the tape routines. They pulled out the serial routines to make room for the speedload stuff. So now we are loaded and ready. Our new driver shows up. Very good. Let's see, this SP32 is running the Bo Zimmerman ZI modem firmware. It defaults at 1200 baud. And yeah, let's save this, because that's what we're playing with now. And terminal mode gives us nothing on the keyboard. All right, let's give the ZI modem a reset. Okay, it is talking. That's good. So we are transmitting from the ESP, and the CIA is receiving it. So that at least tells us the orange one is working, because we're receiving on pin 10 and generating the interrupt off the flag pin. So that's a start. But we're not able to send anything. Alright. I think it's time to scope something. Might be important. Let's get the scope ready. I'll be back. Alright, we got a scope. Let's start poking our probe places. Alright, just for a sanity check, let's watch the data coming into the CIA. We'll reset the thing, the SB. And yeah, we see stuff, so that's good. So now, if we look at pin 1, 2, 3, 4, and we type, we see nothing coming out of it. What should we see? We should see chip select. So that is that guy down there, the, what is that, pin 9 on the 139. Yeah, we hold down a key, we let go of the key. Alright, if we hold down the key, we get chip select. So the driver is doing something. And then we should also be seeing an interrupt. So if we probe NMI, which we can get on our handy dandy PCBWay cartridge here, we get interrupts. So that tells me the driver's working, the computer's working. It's not locked up, obviously. We can still receive data. The CIA is not outputting anything, though. And he's clearly getting an interrupt in a chip select. So CIA is not configured properly, perhaps. So there's a bunch of config registers, and I'm willing to bet the 64 kernel does something to them on boot, and it's probably not in the state it needs to be in. I remember reading about that a while back. So let's see if we can figure out what the kernel does to the CIA when it initializes it, and then see if we can replicate that somehow. Alright, hang on. Let's do some more reading. Alright, just a quick Google away, and I found some neat stuff. So there's a user, Mist64. I think his name's like Michael Steele or something. I've seen this name around before. This guy's smart. A lot smarter than me. So somehow he came up with the source code to the Commodore 64 kernel. I don't know if it's published somewhere or if he actually disassembled this. But dude, thank you. This is awesome. So what I found is this IO init section. And this is the important stuff in here. So D1, see some chips are D1, and ICR is one of the config registers, right, for the 6526. And D1 is going to be the keyboard one, right? CIA number 1 inside the C64. So there's D1 DDRB. So that's CIA 1 data direction register B. We don't care really anything about D1. We're essentially recreating CIA 2 on a cartridge at this point. So we just care about any of the D2 registers that are being set. So when I mean registers, right, there's ICR, PRA, CRA, CRB, and those are all these guys. Your ICR is the interrupt control register for port A, control register for port B, right? So if we send data to, it'd be like DD00, for the built-in CIA, DD01, DD02. This is how you configure the thing. In our case, it's going to be DE60, DE61, DE62. So we could very easily, binary math here, right? So he's loading A with this value and storing that to all the config registers. So we can, I'm sure this can be bolted into the driver. I don't want to screw with the driver yet, though, because, rule of troubleshooting, play with one thing at a time, right? We can do the same thing with pokes in BASIC. So I'm going to translate this assembly of stuff, right? Here he's storing, that's going to D2. So yeah, let's convert this all to pokes so we can do something quick and dirty. All right, here's what I've come up with. A series of pokes that is going to do the same thing that we're doing in this init section of the kernel, subroutine, whatever you call it. I don't know. I'm not a programmer. So yeah, I think I have translated this correctly. So, what do we have? What was the first one? Kill the interrupts, right? So yeah, he's loading a 7F. 7F is 127 in decimal, and then he stores that to the ICR register. The ICR register for DE60 is, what is he? 56941, right? And like I mentioned, ICR, that would be D60D, right? There's our ICR register. And then going to the next one, what did they do? That's right, we're storing this next value to the control register A and B, and that's turning off the timer. So there again, control register A and B is D60E and D60F, right? So this is pretty self-explanatory at this point. All I did was translate the hex into decimal, and actually some of it's hex, right? Like, see there again, like this is in hex, this is in binary. Why? Like, why wouldn't they do it all one way or the other? It shouldn't matter, I don't think. Maybe one day I'll be a programmer and be able to answer that question. But anyway, now that we have all this, we should be able to run it. And that, in theory, configures our chip, our CIA. And I did save that just in case. But yeah, let's fire our little terminal back up and see how we do. Ooh. Hey. He's talking to us. All right. All right, we have data in, data out, and it's after midnight. So I'm quite pleased this thing works. I'm not really going to use this thing as a modem. There's better solutions for modems out there. There's the userport 9600 hack modems. There's the good modem I have in here, the T-Bone modem. Where's that? Is that a good one? Here, we can... Maybe there's something bigger. Yeah, there. Like, that's a modem. That thing's awesome. So I'm not going to bother with, doing much with a modem on this thing. But this gives us a platform to play with. I want to put other things on this ESP module and maybe write some software that controls it. Some kind of Internet of Things, an IoT application of sorts, or I'll make it do something, integrate it with, what's her name from Amazon? I can't say her name too loud, she'll start doing things. Or, I don't know, maybe we'll have it send tweets or text messages or something. But now we have a platform to play with. We have comms, right? We can talk to this thing, and that's pretty slick. So I'm going to end this here. I think my next step is to solder all this onto the cartridge and then maybe write a driver that I don't have to poke a bunch before I load up. So I think that'll be the next thing we do. We'll assemble the cart, we'll get the driver to where it's a prettier package, and then start playing around on the ESP side and see what we can do. So this is probably long enough. I don't even know how long I've been recording, but it's very late and I need to go to bed. So I will say farewell for now, and I'll see you guys next time. Take care.